Okay, in the previous video, I've shown you how to describe the motion of a moving object using a velocity time graph. Now next, I'm going to show you how to calculate the acceleration of a moving object using a velocity time graph. It's going to be very similar to another video which I've shown you, but using a different graph. But when you hear me speak, you'll notice that the underlying concept is still the same. And as we're going to find the gradient of the velocity time graph, which should give us the acceleration. Now take note that I'm leaving this description here, right? Because I'm going to come back to this later, right? To show you that it all ties in together. Okay, they're not different from each other. Don't learn it as separate thing. They all tie in together. Okay, so how do I find the acceleration? So the acceleration equals gradient of VT graph. VT will stand for velocity time graph. And you learn from maths. As of now, when you learn from maths, gradient equals rise over run. So where's your rise over run? Let's take this point. And this point. So what you have seen here, I've drawn a right angle triangle. Okay, I'm going to draw a right angle triangle. Alright, to speed up time, I'm not going to use a digital ruler anymore. But I think you get what I'm trying to say. Now at this point here, 2 seconds. At this point here, 10 seconds. Alright, and this is actually the run. Here I'll draw it up there. This is actually run. So the time increases from 2 seconds to 10 seconds. So that's 10 minus 2 equals 8 seconds. And this is the rise. Okay. So you see, when time increases from 2 seconds to 10 seconds, velocity increases from 5 meters per second to 9 meters per second. Right, your time can only increase, it cannot decrease. So when time increases from 2 to 10 seconds, your velocity increases from 5 meters per second to 9 meters per second. And that will give you 9 minus 5 equals 4 meters per second. Okay, I'll erase this so that it don't look too congested. Right? The velocity increases from 5 meters per second to 9 meters per second, and the difference is 4 meters per second. So that's your rise. And your rise is 4, your run is 8, and that will give you 0.5. And from an earlier video, when you get 4 meter per second divided by 8 seconds, that's meter per second divided by second, you get 0.5 meter per second which is actually equals to 0.5 meter per second square. So what you see here increases by 0.5 meter per second for every 1 second. That's 0.5 meters per second square. Right, so that's how you calculate acceleration. And it ties in closely to the description you put earlier. Right, and as I mentioned to you during lessons before, second square doesn't mean anything. All right, you don't square time. All right, it's actually meter per second per second.